Welcome to our R learning session. Today is a special day because we won't be actually doing the coding itself, but what we're gonna do is we'll go through questions and try to gain knowledge about R coding just by going through question. Is that okay? I hope you are. So let's get started. We have done lots of R coding before. Now, what we're gonna do is we're gonna create a graph that overlays the kernel on top of the stack bar chart or top of the stack histogram. That's what we want to do. And this is a piece of code that does that. In this piece of code, there are many parameters here, but this parameter is important. Bin width. The more you increase the bin width, the smoother this becomes. The lesser you have a bin width, the sharper, the more zigzag it becomes. So that's one thing you want to keep in mind. Now, let's move on to question number 20, which states that as it was said before, the plot was done using default options are for kernel, default option is a Gaussian. There are other options that user can state when running the density command in R. One of the following list of the following, which one following with function is not bell-shaped? In other words, which one doesn't underweight observation at boundary of each bin? Or which one is not bell-shaped? Can you tell me? This one is not bin shaped. This one is not bell shaped. Let's see if it's right. It is. It drops sharply as it gets to the edge. There's no smooth curve here. So that's why it is not bell shaped. And this is the correct answer. Now we move on to the second question. Question number 21. Of the following plots were made by changing the bandwidth of a kernel function R, which one of them was made with largest bandwidth? Can you tell me? We have these choices here. Which one has the largest bandwidth or bin width? This one has the smoothest function, right? This one has smoothest kernel. Therefore, this must be the largest bandwidth. Let's choose this and let's see if I'm right. Shall we? All right, let's do it. All right, this is the right choice. Now, moving on to the next question. One of the things that Professor Duflo also discussed in the lecture was the concept of empirical cumulative distribution. The following figures show ECD of adolescent fertility rate in the world in 1960 and 2000. However, as you can see, the person who made the graph forgot to properly label it. Now, what we need to do is we need to look at this graph and we need to say which one corresponds to 2000, which corresponds to 1960. For this, we need to go back to our previous chart, this one, and take help of that. Here we have been told that there are two overlays here, two overlays here. Dark red. This a dark blue belongs to 1960, and dark blue belongs to 2000, and dark red belongs to red. That's what we know. Correct. Now what we need to do is we need to go back and see how dark blue is just increases sharply as soon as the statistics at first. It's sharply dark blue increases sharply at first. That's 2000 increases sharply at first. Now we'll go back to here. In this chart, we'll see that as soon as zero goes, as soon as we start getting data, it increases sharply. So this must be 2000. Therefore, blue pertains to 2000 while black pertains to 1960. Now let's see if I'm right. There, exactly, I'm right. Now, the last question is that using figure, can you determine whether the distribution used to construct the black series satisfies the first order statistic dominance property over distribution used to construct blue series? Assume the blue point is always above as greater value than black point. The first order statistic dominance property over distribution used to construct a blue series. The first order stochastic dominance. What does it mean? What does the first order statics dominance mean? We need to check that. Let's check that. What does it mean? Uh, our stochastic dominance relations are a family of circuit ordering using distinct theory. There are three types of stochastic dominance theory: zeroth order, first order, and second order. So it defines if all domain event as the following: if for all x and y there exists a value of x, y, such that y is preferred to x, and then y was preferred to x, then y has a first or dominance x. Okay, so what does it mean? It means two things. Using this, we can determine whether distribution used to construct a black series satisfies the first order dominance property over distribution used to construct a blue series. What we are saying is that is 1960 always dominates the blue series. And answer is no, I think, because we always have the blue series that is always dominating the y, right? This is more preferential. If alternatively, what we can say is x is smaller than s and something y. If e belongs to x, if e if the exception of the if the average of e is always less than y. What we are saying is that this is simple. What we're saying is that all the points are all the points in y are greater than y. So definitely it's false because it's actually opposite, right? The blue dominates x all the time. The blue dominates x all the time, so that's why it's false. And so can you determine whether distribution used to construct black series satisfies first order circuit dominance property over distribution blue series? Is false. No, it is yes. Let's see why it says yes. Because you can see that black property has a value lower than blue line. Okay, I can see that. This is the first order dominance for all values. It satisfies for every value of for all value of k given black. All right. So let's summarize what we learned today. We learned about how to construct the graph in R and overlay a graph using this property, the density property, and it gives us some kind of like kernel on top of the stack graph. And secondly, we have this as we know that as you increase the bandwidth, the smoother the kernel function becomes, and it talks about two things here. One is a blue curve and one is a black curve, and it tells us that black curve dominates blue curve all the time because this has a higher probability than the blue curve, and we only labeled that. So that's all for today. I'll see you next learning. Thank you so much.